Hello, my name is Jose Doliner and today I'll be performing lap 8.
Let's begin with part B. Right now we have both hex displays showing the upper 4 bits of the counter and the lower 4 bits of the counter. We also have the LEDs 9 to 2 showing the display of the 8-bit counter. We have two inputs being switch 1 and switch 0, which are enable and clear. We can clear the count or disable the count by switching this low. So when I switch the enable low, I can no longer count by pressing the clock signal assigned to the key 1 push button. When I turn it back up, it allows me to count again. If I flip the clear input, everything goes low again. So we can go further up, see that the counter operates normally. Whenever we get to 9, we can see that also the hex number, instead of being in decimal, it's counting in hex. So we have A, which is 10, and we can see that it's also displayed on the LED. So we have 1010, which is 10, and also A, and we also have a 1, which is 0001. And we can keep further with this and keep increasing the counted state and verify that it works well. When we switch it the enable low, it won't let us count. When we put it clear, it goes back to 0, and it also does not allow a count. So neither when both inputs or when either input is low, it won't allow us to count. So right now, if I put disable off, it won't count. When we put clear and the clear is low, then it won't let us count. One final note for part B is that when we get to the final states for the lower counter, so right now we are at 11110000, which is F0, and we can keep counting, and we can see that the counter resets whenever we get to the final condition. So we will take a look at that right now. So right now we're at the terminal condition, which is all 8 bits high, and when we turn it back up, it goes back to 0, and we can keep counting. So that's it for this part B. Let's begin with part C. Right now we have the clear input set to switch 9. So right now it's low, so the count won't be started right now. Whenever I flip back up, we can see that it starts counting approximately once per second. So we get 1 condition per second, and when it reaches 9, it restarts again. When we put it back down, the counting state goes back to 0.
Right now I have a timer set on my computer so we can test this out. I'll flip it when it reaches 10. I'll flip the switch back up and see if the count works. Let's hope I did it correctly. So yeah, approximately once a second the timer will flip, and we can see that the 8 and the 9s are synchronized. So better way to look at it is this way. When we hide the first number, so we can see that 7, 8, roughly once per second the signal will transition. So that's it for this lab.